All right, so we're going to go ahead and get started. This is the weekly show and tell. Please mute your mics because we can hear us through the speakers. All right. Okay. Here we go. The first person to join the chat was Patrick McCabe. Patrick? Let's get going.
We're going to have everybody show off the project of the week. And if you're not showing off a project, mute your mics. Again, mute them because otherwise you hear background noise. And we want to focus only on the presenter. So the first presenter is...
Patrick McCabe.
Patrick McCabe.
All these people.
Okay, it's still kind of crazy to hear.
Yeah, people are muting their mics, of course, so that's the way it goes.
Okay, better. Yeah.
I think I managed to get a few.
Good.
Yep. Good, Patrick.
This is my reflow toaster oven. So it's a reflow toaster oven. And basically, it's a digital oven. And I took it apart and just added some wires to what buttons led to the inputs of the controller that's inside. So I have access to temperature up, down, start and stop. And this is the controller I built. It's a laser cut. It's got basically just 3 buttons, an LCD, and on the back of the LCD is a surface mount Arduino some Arduino board I made, and there's a second board in there, and I just got the PCBs today. This is what it looks like. It's got a barrel jack connector for power, the Max amplifier IC for a thermocouple. It's the same one you have on your board, and some transistors for these switches, trigger the buttons. And right now, I just finished it today, so I haven't been displaying the temperature, and I can control, basically manually control it, but later, hopefully, I hope to implement PID on it. So, yeah.
Oh, great. What type of things are you going to reflow with this?
Just anything.
Anything?
He's going to reflow more reflow controller boards, of course. Check out, we have some GitHub code that makes a basic PID-ish controlled reflow oven controller, and you can easily adapt it. And it's in our GitHub repository. It's called Reflowduino, and you can pretty easily get it running on your board, and it'll just save you the little bit of effort. It doesn't do like hardcore profiling, but one thing that we didn't notice about doing DIY reflow controllers is that most small reflow ovens are so slow that you don't have to sit at the soak temperature really. You should just ramp to spike. So you would ramp up to like 250, 200 degrees C and then just turn it off. So you don't have to do like the full, like S shape. You can just keep heating all the way up, and that's actually worked out pretty fine for us. So you should try it out and report back on your findings.
Okay.
And never leave it unattended, ever.
Yeah, it's a good.
Speak from experience.
Okay, next up. Thank you so much, Patrick. Next up, Nicholas Lewis. If you can unmute your mic. Oh, are you gone?
I think he's
there. You are.
There you go.
All right,
hey.
Nicholas, unmute your mic and show your project.
Can you hear me?
Yep, we can.
Hi. Okay, so the project I've been working on, you can hear me?
Yep, we can hear you.
Okay, the project I've been working on is inkjet shield.
Oh, that's right, we put this on our blog.
I'm going to move it down here so you can see. Right. So this is my inkjet shield board. So it uses these little point-of-sale receipt printer inkjet cartridges, and there's a multiplexer and some Darlington transistor arrays, and then I designed it so that it's user-selectable pins. So I have jumpers down here and jumpers up here to pick which pins you use, so you can avoid other shields. So right now this is doing a text demo just when the Arduino restarts. So that's printing ink onto the paper there. Here, I'll hold it closer so people can see. So that's inkjet printed ink. It says I Heart Ink Shield on it there.
Oh, that's great.
So yeah, I just started a Kickstarter a couple days ago for this.
That's great. And what type of cartridge?
Darlington transistor arrays.
Oh.
Sorry, what's that?
What type of ink cartridge does it use?
So it's the HP 6602 cartridges. They're a 12 nozzle 96 DPI cartridge. They're used in a lot of receipt printers.
Oh, great.
They're a pretty simple cartridge to drive. They don't have a lot of logic built into them. They're just a resistor array, essentially.
Oh, very cool. And this is great. When what is the threshold for when you can start making these? When Kickstarter gets to a certain amount, what's the amount that you're waiting for?
Sorry, it got noisy. I couldn't hear you.
What is the amount of money that you're waiting on for Kickstarter until you produce these?
So I set the goal at $2,500, which is enough to produce 100 boards. So I'm about I was just over $1,000 a few minutes ago.
Oh, that's great.
Almost halfway in just a couple days.
Okay. Well, for everybody who watches this is a very cool shield, and you're doing it as an open source hardware project, right?
Right. I'm going to release all of the
Great.
source code and the files and everything once I produce the boards.
Everybody should kick in some money. So post up a link in the Google Plus, and if you don't hit your threshold by next week, email us and we'll repost it, and we'll politely ask everyone to support this cool project. It is really neat.
Thank you.
Okay. All right. Thank you, Nicholas.
Okay.
All right. Next up, Joe Huddy. Unmute your mic and show us your project. Hello, Joe.
Unmute your mic and show your project.
Hi,
Hello.
this is a LED cube. Can you guys hear me?
Yep.
Alright, this is a LED cube Arduino shield that I made. I sent the PCBs to China so that they could print it. It took me about a couple months, but I've written 8 programs for it.
Oh, very cool.
Very cool.
Which program did you use to make your PCBs?
Which program did you use to make your PCBs?
I originally made them on EcoPad, but then I needed to transfer it to Gerber. And we're selling them on lookmaterialsmaking.com as a kit.
Oh, wow.
We're going to be at the New York Maker Faire selling too.
Well, this is a great project. Make sure you email us because at you're 14, right, Joey? I think you said in the chat, the text chat, you're 14. So 14 years old, you're ahead of most people who are doing hardware right now because they're always like, well, I don't know how to make kits. I don't know what software to use. Where would I sell them? What would I do? And you're already like 10 years ahead of everybody else. So this is fantastic. How much are you going to sell the kits for?
$15.
Oh, great. And did you build in enough margin so you can have resellers one day too?
Yes.
Okay. We may need to get advice from you later about making kits.
All right, good work, Joe. That's awesome. It's cool to see you learning so much about electronics. LED Cube is a really difficult but fun project because it's like blinky, but you have to be really careful with the soldering. It's definitely really tough to do and make it stand up properly.
Great.
So looks good.
We look forward to competing with you in the hardware in the kit business.
He's going to start Joey Fruit.
Yeah. All right. Bye, Joey.
Okay, bye.
That was great. All right. John Pillman, you can unmute your mic and show your project. Let's see. All right, John, unmute your mic and show your project.
Hey, how's my sound?
You sound great.
Project is all hardware. It's a Cat5 Ethernet cable tester. It's pretty sloppy looking. but I've been using it for about 10 years, and it really works great. On this end is the board, and then I have a short piece of Ethernet cable and a bank of LEDs on this end. And these are just wall mount jacks that I just cut a small rectangular hole in for the LEDs on this side, and on this side, this is also a wall mount jack, and I just sort of strapped the board to the back. I never did even get around to putting it in a box. Okay, so 9-volt power supply. There's a voltage regulator. On this end is a 555 timer, and there's a decade counter, and then a bank of resistors to drive the LEDs. So all I do is plug in a homemade Ethernet cable, and then hook up the battery. I don't know if this will show up.
Yeah, we can see that.
You can barely see it, yeah. There's the LEDs light up in sequence to tell you that it's tested each pin.
Exactly. So,
cool.
It just catches a few of the most common wiring problems, and but it's been very handy. I've kept it around, so I thought I'd show it off.
You should, there's a contest for 7400 logic on dangerous prototypes.
Yeah.
You should enter this in that project, because I really like that you didn't use a microcontroller or any of this like fancy schmancy stuff. you could actually do the whole thing with just like the Schmidt trigger or two and some RCs and decade counter. That's really cool. It's a really good example of simple, low cost, will never break. This will never break.
Yeah, 10 years. I don't think I have a single electronic project that's lasted for 10 years. I don't even know people for 10 years anymore. Okay, John. Well, thank you so much.
That's a cool project.
All right, next up, Cruz, Montreal. You can unmute your mic and show your project. Cruz, unmute your mic and show your project. Yep.
All right. This is a project I've been working on since maybe prior to the beginning of the year. It's based on the LPC 1343 chip. You can see right there it has the standard blinking.
I see blue LEDs.
Yeah, we got power, USB, and just normal blinking LED. The idea was to get something like the Arduino, but in a smaller package. And this is actually an intermin project, because the next revision is actually this right here, which is I'm calling it Root 2, just because each side is 1.4 inches by 1.4 inches.
Okay.
And the idea is that you can stack. It takes the idea of the Arduino, but takes it a bit further to where you can stack all of these different modules, but they won't interfere with each other. So the idea is to have like a small robot, maybe about 3 by 3 inches, that powered by a little cube.
Very cool.
I really like the LPC 1343, and we're starting to see more projects with it. I mean, you can't beat the price. It's like $2. And it's got such a great bootloader that it works on every computer. So, yeah, I can see why it's becoming very popular with people.
All right. So we've got about 13 minutes left, so we're going to try to get through everybody else fast as we can. Cruz, thank you so much. Post up links to your project in the Google+, and also email us if you want us to post it up. Bill Porter, you can unmute your mic and show your project. Bill Porter. And the faster you can talk and show your project, the better. Hello.
Can you hear me?
Yes, we can. Talk fast.
Oh, hi. Lamore, I owe you thanks first off. I'm the guy that built Tesla Hero that you voted for, and I got the 3D printer. So thank you.
Woo! That's great.
So I work for the Navy, and one of the things I get to do with the Navy is twice a month I get to go to elementary schools and put on a show to get kids interested in science. And one of the things I've been building for that is an LED lab coat, and hopefully you can see a video of it quickly here. I'm not really fancy with the video software yet.
That's fine.
That's a demo of the LED lab coat I've been building. That was just a test run. I'm actually working on the controller now. And the controller is going to be something I wear on my wrist that I can actually do audio cues from. This is the first version, so you can see that there. So it's a custom-built board with an LCD screen on top and a little XP slot next to it. It's going to run my lab coat, show me what cue is coming up next in the show. There's going to be a touchpad to the right where I can hit the button to activate the next cue and actually do something. And it's going to send commands to a box that will play the audio cues for the sound system during the show. And actually, I had Patrick McCabe, the first one to show up tonight, wrote me some software to help me out. Let me see if I can show that real quick. That's some software and Python that he wrote for me to program light shows in my lab coat. So I can select one of the bars and change the RGB values and save a frame and then save a whole show. That's later going to be saved to an SD card that's going to go into my controller, and then I can go on stage and perform for the kids.
This is great. This is really raising the bar for lab coats. You just can't show up anymore. There was a video.
There's a video code
that we saw.
That was a Burning Man. It was actually showed like full frame video.
Yeah, this is great.
And now this. It's hard to see the video through the Google, so be sure to post a link to a YouTube video or something showing this lab coat. We do want to check it out, but unfortunately, we couldn't really see very well. But the imagination.
I'll post it up right away.
Yeah.
The imagination boggles.
Yeah. All right. We're going to keep trying to move on. Thank you so much, Bill.
And actually, if you guys want to see me on stage,
yep. Wait.
you're welcome. See you guys.
Oh, no. Go ahead. Go ahead. Continue, Bill. Sorry.
You're good. I was going to say, if you want to see anything about the show I do for kids and you can actually watch video of it, it's sciencebrothers.org.
Okay, great.
It's actually kind of cool. I love that I get to do that. And that being an engineer for the Navy still affords me time to do that.
Oh, excellent.
Awesome. Go Navy.
All right.
Cool. Thank you so much. Next up.
Brandon, unmute your mic and show your project.
Hi. Unfortunately, I don't have a project, so next person.
Okay. That's
you have
right.
to show a project.
Next week you have to show a project, otherwise we're going to come to your house and demand a project.
You can't show here without a project.
All right.
Okay, that's fair enough.
To get in the door, project required.
All right, Chris Connors.
Chris Connors.
Show your project.
You're up.
You may want to...
Unmute your mic so we can hear you.
Unmute your mic. Chris?
All right.
Okay, there you go. Show your project.
Can you hear me now?
Yep.
All right, good. So let's see. This is a little earbud holder. There we go. Earbud holder for headphones. And it was based on a design by Brett Beauregard. And it's set up in OpenOffice. And basically, I did it as a sample for a student project that I'm going to have kids do this coming year.
Oh, cool.
In my program, and I think this will be a bunch of fun.
Is that a laser cut acrylic plastic piece, or what is it? What is it made out of, and how do you process the shape?
So it's a laser cut acrylic, and I also had students, or I'll have students do it in cardboard first, because the speed is so much faster with cardboard.
Yeah.
And also they'll be able to just figure it out. It's cheaper, it's quicker, and then they'll go through. I went through 6 designs before I got one that really worked well. And so this will be fun. Then they can etch a picture onto it as well.
Mm-hmm.
Very cool.
That's cool. I think it's neat how laser cutters, which were like $50,000, super rare machines, they're like in every high school and college nearly. Like they're starting to become very common. Such a powerful tool. You know, you draw something in Inkscape and print it out.
Okay, Chris, we're going to move along to the next one. We got 2 more people we're going to try to get in. Matt Keeter, unmute your mic and show us your project. And then right after that, we're going to try to get to Christopher Robinson.
Hi, guys.
Hey, Matt. Show us what you got.
Big clock, because everyone makes clocks.
Okay.
So it's 2 layers stacked PCB. And the cool part is if it's sitting on your desk or hovering in the air like this, it's in a sleep state where it uses very little power. But as soon as you kind of pick it up and put it in the palm of your hand, it senses that and turns on and shows you the time.
Oh, cool. Can you show it again? The video is a little sluggish getting to it.
Okay, so in midair, nothing's up my sleeve.
Yeah.
As soon as you actually have your palm against the back of it.
Oh, yeah. Very cool. And where can people find out more about this project?
I'll post a link on I'll comment on the Google Plus link.
Oh, great. Yeah, and also send a note through our contact form. People love making clocks. It's one of the best things that you get to show.
And they love capacitive touch sensors. So this is just like a mix of everything good in the universe.
It's an electronic goodness sandwich.
It's like magic. I say capacitive touch sensing's been around for 20 years, but it's every time I use something with capacitive touch, I'm like, wow, magic.
Okay.
How does it know I'm touching it? So cool.
In this case, I actually just have a copper flood on the back of the PCB, and I use that as the big capacitive metal pad.
Yeah.
That's cool. All right. Next up, Christopher Robinson. What do you got?
Today. I'm a huge fan of these Wii cameras. I love the Wii cameras, but they need a clock signal and a reset circuit to make them work. And so I made this cute little breakout. Also, the pins are wicked fine pitch, and they're hard to solder. So I made a nifty little breakout. It's got the oscillator on it and the reset circuit. And on the back, it has a Soto horn, so it fits nasally on top of the servo. And because I bought the Wiimotes from eBay and I had them, I made breakouts for the nunchuck connector as well. So if people don't want to use the little 1/4 inch wide PCB stuck in the connector to connect to the proper connector with mounting holes. And that's it.
Very cool.
I have a question. Are those Wii cameras IR only? I thought the Wii was only infrared.
It's amazing. It's infrared or near infrared. The laser I use for my laser radar is 680 nanometers. 650 is a regular red laser pointer. So pretty darn red all the way into infrared, and it'll work.
Right. Good for computer vision projects. There's not a lot of confusing stuff. You know, it doesn't get confused by different colors or lights because you can.
No, it's incredible. You get a nice clean X and Y for 4 points of light, as well as size and intensity. It's I2C. It's simple. I love them. I love them. I love them. I love them.
Very cool.
All
Okay,
right.
we have time for...
We love you too.
Yeah, for maybe one more, and then we have to do Ask an Engineer. Harry Johnson, do you have a project that you're going to show? Harry?
Yeah, very quickly.
Okay, great.
Quite quickly.
Yeah, please do.
Okay, all right, so I can't really see myself.
That's okay. We can see you.
This blinking LED. And, all right, and more importantly, I have this other little circuit attached to it here, which has an SD card, which has a bunch of hex files on it that were generated by the GCC. And by pressing these buttons here, I can select which file I want, and I want the faster blinking light, and do this. And this chip here, which is an Atmega, will talk through these wires to this other chip and actually bootload it with that hex file. I found all the SDK500 protocols and all that, and now that is blinking faster. I wish I had a backlit LCD because then you can actually see that there's a loading bar and all that. But as it stands right now, that's what it is. I want to make it a 32U2 with a built-in programmer, so it can actually. It's kind of USB Tiny ISP compatible, except that you can actually record programs on the way through and then download them again later, like the PitKit, a version of the PitKit for the AVR.
Oh, that's cool.
That's ironically exactly what I've been working on all day. I'm working on a standalone chip programmer. I'm not using the SDK500. I'm a lot I'm not lazier, but I want to basically be able to just program chips on the fly. But what you're doing is really interesting because a lot of times, like you want to be able to like use like a cassette, like not a cassette, but like a cartridge to load a chip. So this is kind of a cool idea of using a.
That's what I was thinking by. That's what I was thinking with the SD card, because you can just grab if you use the verbose, you can just grab it and just support. But I know you guys have that going here to get to, so.
Yeah, it's kind of like all the futuristic science fiction movies where when they need to like play a video, they have a little tiny disc that they put in.
Yeah, like make me like tea, and then you put in the tea cartridge.
You put in the tea tape or whatever.
Oh, I want egg cartridge. So it's kind of it's a little bit like that.
Okay, everyone. Well, thank you so much. This was fantastic.
We had awesome projects.
Yeah.
That was like 12 great projects.
Yeah, we'll see everybody on Ask an Engineer in a few minutes, and we'll see everybody here next week. If you didn't show a project, remember, we're going to come and find you, so make sure you
we have a list.
Show your project next week.
Show your project.
Okay, bye, everybody.
Bye.